In this video, we'll take a look at the gear modeling assignment and the steps that you'll need to do to complete a 46-tooth gear with the established parameters. So let me bring up, this is what we're looking at. We're looking at a 46-tooth gear with a diametral pitch, which gives us 6 teeth per inch. We have a pressure angle of 20 degrees, an addendum of 1 over the diametral pitch, dedendum. So these are standard. Fillet radius is given at both the root and the tip of the gear tooth. And then this is material thickness and center hole diameter. So this should drive our design table and gear model. So what we're trying to get to is a model that looks like this. I have a pretty, well, it's not complicated, it's just a little bit hard to look at sketch here that shows all of the circles. You can zoom in here. Here's my gear tooth profile. So I'll need to create that base sketch. And then my first extrusion is just, if I roll this back to show you, it's just the dedendum circle. Then I use the same sketch and I extrude a single gear tooth. I put in the fillets at the root and tip of the gear tooth. I don't know if you could see that, but it starts with hard edges, which we never want in machining. It's also very hard to make. So now we've added our fillets and the hole in the center. And I've got one gear tooth with a bunch of fillets. I need to pattern that around the whole gear. So that's the process. So now let's look at how we set up that first sketch. So I'm going to start a new sketch on the front plane. And the very first thing I'm going to do is, oops, that's not centered. I'm going to center my circles right on the origin and put in my 4 circles. So I have dedendum, base, pitch, and addendum. So the addendum delineates the top edge of the tooth, the tip of the tooth. The dedendum is the root of the tooth. Base circle is where our involute curve starts, and the pitch circle is where the width of the tooth is exactly equal to the width of the space between teeth. Now I just selected the middle 2 circles. I want to make my base and pitch circles for construction. So that's that. And then the next thing I want to do is I want to put in a series of points. It doesn't really matter where they start or where they end. That's what our design table will set up. But it does matter that they're pretty easy to dimension. So I should make them so that every subsequent point is up and to the right of its previous point. So kind of a linear pattern here. Now I need to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think I suggested 13 points, but you can play around with that, how many points that you need. That's it here. So now I'm going to fully define the sketch and name my dimensions. So if I come up to Tools and come down to Dimensions, I can find Fully Defined Sketch. And the defaults are correct. I want to do all entities. Checkmark puts it in. And now I have, and I can kind of rearrange these so that they're a little bit easier to get to. I have 4 diameters, right? And I should have, let's see, probably if I did 13, I should have 26 linear dimensions here, with my horizontal dimensions being x's and my vertical dimensions being y's for each of these points. So the next thing I'm going to do is I'm going to turn on the visibility of dimension names by selecting the pull down here and choosing dimension names. I want to show you that occasionally this gets toggled, and now I can't do anything. So if you find that everything is grayed out, hit the toggle again, and you should find that the features can be turned on and off. Okay, so I'll show you. If you select the number, SolidWorks now assumes you want to set a dimension. If you select the line attached to a dimension, you get all of the dimension properties. And that's what I want to do for all, that's 26 plus 4, so all 30 of these dimensions need names. This dimension, D1, goes to my dedendum circle, so I'm going to rename this. I'm not going to spell the whole word out. There's no particular reason to be careful with that, as long as I understand what they are. So I'm going to go through and label each of the diameters so that I know what they are in my design table. And that's really the point here, is when I set up my design table, I'm not going to know what D1 and D14 mean. I will know what my diameters and X1, Y1 mean, right? So that's what I'm trying to do here. So if I zoom in, I can see D5 is my first X. So now this part is a little bit tedious. But let me do the first couple here. We're just going to name each dimension sequentially. And it really doesn't matter if I'm not paying attention and I mix up and I say that this one's X4, that's okay. What matters is that X4 and Y4 go together. So, so probably it's best to keep it sequential. It's easier to keep track of X1, X2, X3. Then I'll come up here. This will be Y1, Y2, Y3. Careful to check those arrows, then you don't have to do quite so much clicking, right? Okay, so we're going to do all of these steps. And now I insert tables. Oops, I can't do that inside the sketch. So I can't pause the video. So I'm just going to show you the very next step, and then we'll go into a file where everything's set up. Once you have all your dimensions named, you return out of your sketch hitting the arrow, not the X. The X deletes all changes. Come up to Insert Tables, and now we want to insert a design table. So I'm going to hit the check mark here, and here's where you would select all of the dimensions in your sketch, and then I get this design table. It's really hard to look at in this window, so you're going to want to pause the video at this point, name all of your dimensions, and insert your design table, and then click out right like this, and that's where we're going to continue. So pause the video, do all that, and then come right back here, and here is what I've got. So you can see that all of my dimensions are named, right? And everything's magenta. It's all magenta because it's in the design table. So we're going to, so you should have something that looks like this. Maybe you're outside of the sketch. So you have something that looks like this. Your points don't look quite as nice as mine, but that's because we haven't set up the design table. So come over here. Third tab in is Configuration Manager. Right-click on Design Table and Edit in New Window. This allows us to edit the table in Excel. Excel works better in Excel, not surprisingly, right? So, so we're going to open this up in Excel, and bear with me for 1 second. Oh, that's right. We have to go back to SolidWorks. This is a new feature where, oh, come on. It's trying to get me to select new items. So it gets sometimes it looks like it gets a little frozen. Let me size this properly to the window. Okay, so you can see all my dimensions. I'm actually going to shorten these up a little bit so I can see more to go. In fact, I think I can do this. Okay, perfect. So these are my diameters, dedendum, base, pitch, addendum. These are my X dimensions. These are my Y dimensions. So I've inserted my information here. I have the number of teeth. I have the diameter pitch. So this is the pitch diameter. We divide the number of teeth by the teeth per inch, and we get the diameter necessary, right? My theta, I turned this into radians by typing this formula. There's pi radians in 180 degrees of a circle. So when I do trigonometry, when I do a cosine or a sine, I need to be in radians in Excel. So I did that here. My addendum was 1 over the diametral pitch, and dedendum was 1.25. So I'm going to need those for my diameters. Okay, so now it's just a matter of assigning my diameters. My pitch diameter is exactly D. My base diameter is D times the cosine of theta, right? The pressure angle. My dedendum, I take the pitch diameter and I subtract the dedendum twice. My addendum diameter, I add the addendum twice. So those are the first 4 items in my design table. The only numbers that matter are in this row. Everything else I can do whatever I want in this spreadsheet without affecting the sketch. Okay, next step, I have my thetas here for my involute curve. And now I'm going to take the base circle divided by 2, that $ keeps it stuck on this row. And here's my involute curve. So that's the base radius, right? The base radius is the diameter divided by 2. Cosine theta plus theta sine theta. This isn't the pressure angle. This is my involute curve theta. That's my x value. Y value is the same base radius, but the involute curve changes. It's sine theta minus theta times cosine theta. So that's that. I was tracking my points. It looks like in this part I made 14 points. So now let me redo this part because this is a little bit sometimes confusing. So I'm going to pre-select my X cells. Oh, that's funny. I only have 13, so I have one too many down here. That's okay. So I pre-select the row, and then I type my equation. Equals the transpose of. And now I select the numbers I want to plug in here. Oops, I have to make sure I only select the right number, so 13. And now, Control-Shift-Enter all at once plugs these in. It's funny what happened. Oh, I have a numbering problem. Okay, so we're going to try this again. 20 equals the transpose of, so there must be 14. That's why I have 14. Control-Shift-Enter. And there we go. So if you get any errors, just do it again. Double check your numbers match. So this must be x14. I must be off by 1. And I do the same thing with my y's. So I select all. Yep, there's 14 y's. I select them all. I type both equals transpose. I select my y's. Control-Shift-Enter. There it is. Now the nice thing about this is it's not a strict copy-paste transpose. It is actually linking this cell to this cell. So if I change my thetas, or if I change my base diameter, if I change anything here, they all update. So if you change from a 46-tooth gear to a 40-tooth gear, you can use the same file and design table and update your sketch very, very easily. That is the huge advantage here. Okay, this part might make you nervous. You don't have to hit save. You just close out of it. It dinks you back into SolidWorks and it updates it. So by now, you should have something that looks very much like this. Okay, so the last step for this sketch, well, I have to say the last 2 steps. I have to build a spline, and then I have to mirror the spline to get the other half of the tooth. So let's come back to our sketch. Edit sketch. I want a spline right here. So I'm just going to go ahead and connect all these points. And this is why it matters that I turned the base circle and the pitch circle into construction circles, because SolidWorks won't interpret those for extrusion. It'll only extrude the piece between the degen and addendum circles as far as the gear tooth goes. I right-click and select to end the spline, and there we go, there's my spline. So the last bit is, how do I mirror this? How do I get the other half of the gear tooth? Well, I'm going to need 2 construction lines or center lines for that. The first one goes from the center of the circle over to the intersection of the spline and the pitch circle. Double-click starts a new line. The second goes from the center of the gear to somewhere else on the pitch circle. And now let's talk about what this angle has to be. So this is the center of the gear if I'm mirroring, center of the gear tooth if I'm mirroring the spline about it, which means I'm going to need the angle here to be half of the total angle of the gear tooth. Agreed? The next thing I have to remember is that I don't have just 46 teeth, I have 46 spaces. So I need the angle between these 2 lines to be the 360 degrees divided by the total number of spaces and teeth twice that, because I've cut it in half. So I'm going to divide by 46, and I'm going to divide it again by 4. And that should give me about 2 degrees. And there it is. So this one I didn't plug into our design table. If you were to change this file to be a different number of teeth, you'd have to come back here and change that value. Okay, so I turn off my dimensioning tool and I come find the mirror tool, mirror entities. I want to mirror my spline. I want to mirror about this line. I want to make sure I'm copying, and I hit the check mark. So this is the area, that's my gear tooth. And that's it, I'm done. I'm going to return out of this sketch. So the next step, I extrude. I select the sketch I want to extrude, and I'm extruding the center of this here. Because I selected that circle, it's assuming that's what I want to do. Oops, that was the wrong amount. 0.375. Okay, tricky step here. I'm going to select this sketch again and extrude. And now it's saying, well, I've already extruded once. What do you want to do now? So I'm going to select this contour right here and make sure it's 0.375. Check mark puts it in. Now, I've already selected a material. If I remove the material, it'll look more like yours. There you go. Okay, so moving real quick here. Fillet, root, tip, tip and root. And I think, so for right now it's 0.08. We might change that to actually create it in the machine shop. But I have full preview on. If you have no preview and you want to see what's happening, go ahead and turn that on. Check mark puts it in. I'm ready for a circular pattern. And, oops, I always do that. Control, there we go. So I want to select the fillet, but I also want to select the gear tooth. I want equal spacing, and I want 46. So make sure all that's set. Oh, I need a direction. It doesn't know where to go. Around the edge of the circle. Check mark puts it in. Very last step is a hole wizard. I usually do a hole wizard. I mean, you could certainly do an extrude cut. Last one I did is the correct one. It's a through all 3/8 hole. Position. Snap to the origin. Check mark puts it in. Last but not least, I'm going to apply ABS polycarbonate. It's a plastic that's got similar properties to Lexan, the name brand that we're using. And there's my gear. That's it. So if you have questions about any step in there, certainly ask in class, email, stop by. Hopefully that helps you get this assignment made. Check the example drawing for what's expected on your drawing. And that concludes this video.